Okay, we're finally here. It's the final part on commenting on an article that I'm mostly reading and then adding extra snippets into. But anyway, revisioning. Version control is now seen as an indispensable part of professional software development, and GUI IDEs like Eclipse and Visual Studio have embraced it, including support for industry standard version control systems in their products. Modern version control systems trace their lineage back to Unix concepts from programs such as diff and patch, however, and there are plenty of people who will insist the best way to use a version control system is still add a shell prompt. In this last article in the Unix as IDE series, I'll follow the evolution of common operating system with a common open source version control systems from the basic concepts of diff and patch among the very first version control tools, diff, patch, and RCS. A central concept for version control systems has been that of the unified diff, a file expressed in human and computer readable terms, a set of changes made to a file or files. The diff command was first released by Douglas McIlroy in 1974 for the 5th edition of Unix, so it's one of the oldest commands that's still in regular use in modern systems. A unified diff, the most common and interoperable format, can be generated by comparing two versions of a file with the following syntax: diff-u example 1.2.c, and then you can output that to a patch file and then you can send it to someone. But anyway, in this example, the second file has a header file added, and the call to return changed to use the standard exit success rather than a literal 0 as a result as a return value for main. Note that the output diff also includes metadata such as a file name that was changed and the last modification time of each of the files. A primitive form of version control for larger code bases was thus for developers to trade diff output called patches in this context so that they could be applied to one another's code bases. With the patch tool, we could save the output from diff above as a patch file, so diff-u example, and outputs it to an example.patch. We would then send this patch to a developer who still had the old version of the file, and they could apply it with patch example, and then you other way caret to example in example patch. A patch can include diff output from more than one file, including with subdirectories, so this provides a very workable way to apply changes to a source tree. The operations involved in using diff output to track changes were sufficiently regular that for keeping in-place history of a file, the source code control system and a revision control system that has pretty much replaced it were developed. RCS enables locking files so that they could not be edited by anyone else while checked out of the system, paving the way for other concepts and more developed version control systems. RCS retains the advantages of being very simple to use. To place an existing file under version control, one need only type CI file name and provide an appropriate description for the file. This creates a file in the same directory. Example CV will track the changes to make changes to the file. You check it out, make the changes, then check it back in. You can then view the history of a project with rlog, and you get a patch in unified diff format between two revisions with RCS diff-u. It would be misleading to imply that simple patches were now in disuse as a method of version control. They are still very commonly used in forms above and also figure prominently in both centralized and decentralized version control systems. So one example of this, if we go to suckless.org, if I could spell suckless wrong, it's not double C either, it's CK. And we can go to DWM and we go into patches. This is where you see a lot of hacking put into it. So where a code base may not want to implement certain features into it, but allow for hacking nonetheless for people to submit their own features to it, you can do that. So we could allow alpha with the alpha patch for the top bar and so on. And all we have to do is take this patch here, which patches multiple files here as noted in the post. So you've got config.def.h that takes changes. So that's our config template Then our config.mk needs some changes. Our drw.c takes changes, our drw.h, and our dwm.c takes a lot of changes. So we can scroll through these changes and see what's removed, what's added, and then it separates it by file as we go. So we can see that, and in some cases it will add files. So if I go to like DWL, for example, on Codeberg, we can go, let's see. So much like DWM, DWL is lightweight and has a whole patches repository now. So we could go into, I don't think it's not needed anymore. So there used to be a desktop patch that would add a desktop file. So you could add completely new files to it on top of the others. So you would have the source code in that diff file. So it would add a file to the source tree and go from there. So I don't know if, let's look at the tab patch. Let's see, dwl.c make file. Let us see. Adds a whole bunch of code. I am hoping to find one that adds a new file to it rather than just back and forth. Let's try the swallow patch. Client.h, that's already in there. Title urgent. I don't think we're going to find one that adds a new file anymore. But pointer gestures unstable. Let's I guess not. KB layout, IPC, gapless grid, env, drag m fact. No. Well, anyway, you kind of get halfway the point. And then from there, you basically go into patch. I've done videos on patching for DWL before, and you would follow that process in order to patch the source tree, and it'll apply those changes to every file listed in there. So now, CSV and subversion. To handle the problem of resolving changes made to a code base by multiple developers, centralized version systems were developed with a concurrent version system, CVS, and developed first and slightly more advanced subversion later on, or SVN for short. The central feature of these systems are using a central server that contains a repository from which authoritative versions of the code base at any particular time of revision can be retrieved. These are termed working copies of the code. For these systems, the basic unit of the system remained the change set, and the most common way to represent these to the user was in the archetypal diff format used in earlier versions. Both systems work by keeping records of these change sets rather than the actual files themselves from state to state. Other concepts introduced by this generation of systems were of branching projects so that separate instances of the same project could be worked on concurrently and then merged into the main line or trunk with appropriate testing and review. Similarly, the concept of tagging was introduced to flag certain revisions as representing the state of a code base at the time of a release of the software. This concept of the merge was also introduced, reconciling conflicting changes made to a file manually. So merging is really cool, but anyway, that's kind of where, like, when you merge a file, sometimes you have to go in and take care of conflicts. So like with DWL or DWM, like I've done in previous videos, you have to, what was it? You have to manually resolve conflicts between patches and the code base that is there now after applying multiple patches. So sometimes it means you're taking things out or changing things in order to make everything work together well. So this applies both with DWM and DWL. So Git and Mercurial. The next generation of version control systems are distributed or decentralized systems in which working copies of the code themselves contain a complete history of the project, and are hence not reliant on a central server to contribute to the project. In the open source, Unix-friendly environment, the standout systems are Git and Mercurial, with their client programs Git and HG, both of which are commonly used now in the AUR when you are compiling your own systems. For both of these systems, the concept of communicating change sets is done with the operations push, pull, and merge. Changes from one repository are accepted by another. This decentralized system allows for a very complex but tightly controlled ecosystem of development. Git was originally developed by Linus Torvalds to provide an open source DVCS capable of managing development for the Linux kernel. Both Git and Mercurial differ from CVS and Subversion in that the basic unit for their operations is not change sets, but complete files, blobs, saved using compression. This makes finding the log history of a single file for the differences between two revisions of a file slightly more expensive, but the output of a git log patch still retains the familiar unified diff output for each revision, some 40 years after diff was first being used. So this lets you generate a patch, for example, for DWL or DWM based on changes that you made to the code to complement your workflow. And then later on, apply it back again as needed. The two systems have considerable overlap in functionality and even in command set, and the questions of which to use provoke considerable debate. Best introduction I've seen are by ProGit by Scott Chacon and HGinit by Joel Spolsky. So Git is really, really popular. It's what Codeberg uses. It's what I think Suckless largely uses for their repositories. If we go back to DWM, so you can git clone. Many are using Git now. It's the more widely used one, hence GitHub and Git and so on and so forth. So it's very popular, and in some ways you can just git apply, which I've shown, many of these diff file or patch files on a repository, and it will allow you to track the changes and will error out if you try and apply those changes to files that aren't, quote, in the commit to the source anymore. So, which is really cool. So these version control systems have a lot of power now for collaboration as well. And a lot of people use it for more than just source code, like note-taking and so on, to sync their notes and such to a server. So you could host your own Git server and keep track of your notes and other projects on your own server using these modern tools, and then create patches of things and have version control and back up to a certain commit point and move forward to a certain commit point. So if I go back into projects again, well, actually, I just go into projects, GitHubs, let's go with Linux TKG. I can git pull, and you can see I pull down the changes that I need, and I guess it doesn't overwrite my customizations anymore, it seems, but you've got a lot of options in here, and it shows you what goes on with the git pull. So, and then if I needed to git merge locally, I could do that. But I've also got the full revision tree that I could upload to a separate server and create a new origin, so I could get pushed to two separate servers at the same time and have the same revision tree on top of it. So even projects like Suyu would have the full revision history of, would have the full revision history of Yuzu, I believe, because of the way that Git works. And yeah, so conclusion, finally, this is the last post in the Unix's IDE series. I've tried to offer a rapid survey of the basic tools available just within a shell for all the basic functionality afforded by professional IDEs. At points I've had to be not quite as thorough as I'd like in explaining certain features, but to those unfamiliar to development on Linux machines, this will all have hopefully given some idea of how comprehensive a development environment the humble shell can be, and all with free, highly mature, and standard software tools. So again, many of these tools are also available on BSD. So you can do a lot of this same functionality on BSD and other systems, and very basic bare bones Linux systems. So you're not limited. You've got a whole broad system that you can use. And on top of that, you've got more tools at the command line that you can take advantage of that are a short install away. If you enjoyed the video, then like, comment, subscribe, feed the algorithm, boost the video up, share this video with your friends. If you found it informative or you just want to chat, I've got plenty of places in the description, Discord, Guilded, and what have you. Check those out, and I will see you guys in the next one.